Imagine if the sun were smaller than the Earth. Would life still exist? Would the planets remain in their orbits? Or would the entire solar system collapse in an instant? To visualize the sun's size relative to the Earth, imagine shrinking the sun down to the size of a basketball. In that case, the Earth would shrink to the size of a sesame seed. This shows just how massive our star is. But what if this fiery ball of gas and plasma wasn't the largest object in our solar system? Would our planet still orbit the sun? Or would the sun orbit the massive Earth? And what would happen to our neighboring planets? Our sun is so enormous that it would take about 1.3 million Earths to fill its volume. The sun's mass makes up 99.86% of the total mass of our solar system. It only seems small when viewed from Earth because it is 150 million kilometers away. If the sun were hypothetically smaller than the Earth, then Earth would become uninhabitable, and perhaps the sun wouldn't even qualify as a star. In the universe, two things are crucial: size and distance. Earth's position is precisely calibrated. It sits in the safe zone of the solar system. If we were as far from the sun as Mars, we would freeze. If we were as close as Venus, we would burn. So Earth resides in the sun's habitable zone. This means that the sizes of our planet and the sun, as well as the distance between them, are just right for life to exist. But what would happen if the sun were smaller than Earth? A star's size determines its color and temperature. Larger stars are hotter and appear blue, while smaller stars are cooler and appear red. Our sun is a white star. It is neither as huge as supergiants nor as small as red dwarfs. You might think that if the sun shrank, it would become a red dwarf in a tiny habitable zone. But that's not the point. A star, whether a supergiant or a red dwarf, is still a star as long as nuclear fusion occurs in its core. But how small can stars actually be? At this point, not many red dwarfs have been measured, but the smallest measured red dwarf is about the size of 10 Earths. This is very close to the theoretical lower limit for sustaining nuclear reactions in a star. Anything smaller wouldn't be a star at all. It would be just a cold, dark, stellar remnant. So, if for any reason the sun shrank to a size smaller than Earth, it wouldn't have enough mass for nuclear fusion. It would go completely dark, and our solar system would lose its only star. Since the sun is the source of gravity that keeps the planets in orbit, its disappearance would send all the planets, including Earth, drifting through space in search of another anchor. This is definitely not a happy ending for life on Earth. Let's consider another scenario. This time, imagine that Earth became larger than the sun, while the sun's size remained the same. In this case, Earth would need to be at least 333,000 times its current size. A planet of this size would generate enough energy in its core to become a star itself. Naturally, no life could survive on such a scorching star, but something amazing would happen in our solar system. There wouldn't be just one sun, but two. Our solar system would become a binary star system, with the two stars orbiting each other while the planets orbited around them. In either scenario, life on Earth would have no chance of survival. Yet, according to some scientists, life might arise on another planet or even on one of the moons. Binary and multiple star systems have been found in distant regions of the universe, and some already have habitable zones. In the end, it's clear that the sun's size and Earth's position are not coincidences. They are a precise cosmic balance. Even a slight change in the sun's size would have made life on Earth impossible, turning our solar system from a home for life into a silent cosmic void.